This is for you. Law of Science, ambiguous case. Anyone else want to say happy birthday? Is it really her birthday?
Yeah.
Say happy birthday.
Yeah, we should.
Okay, ready, set, and go. Happy birthday to you. Happy birthday to you. Happy birthday, dear Savannah. Happy birthday to you. Okay, that's enough. All right, let's stop. So, law of science ambiguous case. It's a little bit tricky. It's when you have a side angle, also known as ASS, and you couldn't usually use that last year or before because it spells a bad word. But also, we told you last year with congruent triangles that it doesn't work. Well, it turns out that it does work in some cases, side angle, to solve a triangle. So say I have a side here, and, well, let me change that. Let me make this side, one side go on forever. So let's pretend that this side goes on forever. We don't know how long that side is. And then I have another side going this way. Whoops, I want to make that a finite length. So I have another side going this way, and this side has a given length, and this other side has a given length over here. So say you know this side and this side. You don't know this side, but you do know this angle. So say you know this angle is theta or something like that, or A or B or something like that. The reason this is an ambiguous case, well, we'll call this side 1. Let's call this side 1 and side 2. Because it is possible that if this side is long enough, you see that, it will reach this side. Okay, and then you would have a triangle. If this side is, but let me just show you something else. If this side is, so if it's long enough, it's going to reach the side. If it's too long, well, could it be that, what would have to be true in order, between side 1 and side 2, in order for this thing to make a triangle, given two sides remain?
They'd have to add up correctly.
What?
You'd have to, like, if you add them together, they would be less than the
Yeah, but we don't know what this third side is. But what about the length of side 2 compared to the length of side 1?
Too small.
Side two has to be small.
In one case, it would have to be bigger, right? So if I took this, so one possibility, I'm going to go through all these possibilities in a minute. So if I make it bigger, right? So one possibility is that it could just reach and it can exactly touch a side. But I could also take this same side and flip it over to over here if it's the same length. You see that? And then I would have different triangles. Isn't that cool with my movie board? The other part, so there's, if this side is a given length, meaning it's in between, it's less than this side but more than this h right here, then I could have
to be more than
because if it were less than it, whoops, because if it were less than h, then it wouldn't reach, right? How do I move it? Like this? I should do it with some other. There, okay? Because if it is less than h, right, then it wouldn't reach the other side. The other possibility is that it's exactly the same length as h. Oh, I'm trying to be so innovative, it's not working too. Let me see. Drag. No. How do I drag down here? No. How do I? There. The other possibility is that it's exactly equal to h, in which case I'd have one triangle. The other possibility is that it's way longer than the other side, in which case I could only, if this side is bigger than this side, how many triangles could I make? Exactly one. Okay? If it's less than this side but bigger than this h right here, then I have two triangles. If it's less than h, then I have no triangles. And if it's equal to h, then I have one triangle. So that's, I'll write all this down. Okay, so I'm just kind of trying to show you in general. So let me show you all the possible possibilities with the ambiguous case. That's why it's ambiguous, right? And so the first, let's do this as solid. Ambiguous means it's not quite. I need to make that a solid line. One more try. I should have rehearsed before I recorded this video. Oh well. So here we go. So case one, and all the first we're going to go through all the cases where A is an acute angle. Acute meaning less than A. A is an acute angle, and A is over here. And I want to get rid of this thing again. Sorry, I keep screwing up. Edit. No, yeah. Cut. Alright, so I'm going to make this with a solid line. Alright, no arrows on it. So here's A. And this side is here. And then I'm going to draw it in H dotted line. So H is not part of the triangle. Okay? So side-side angle, A is an acute angle. Case 1. Case 1. This we call A over here. We'll call this side B over here. And we'll call this H over here. Okay? So in this case, A is less than H. How many triangles do I have?
0.
No triangles. So that's case 1. No triangles. And what I would do if I were you guys, when you're setting up these things, they're going to give you an angle, they're going to give you a side, they're going to give you another side. I would always set them up in this orientation. That way you won't get it confused. It doesn't. You could orient it where the side A is over here, and side B. But I would always call this angle A, side A. Angle B would therefore be over here if you had a triangle. Side B, angle C, and side C. That way you won't get confused. You could be kind of consistent. But it'll work the same way if you flipped it around, but just to kind of show you. So case 2, okay, is going to be if A equals H. So if A equals H, then I would have, so I don't want that dotted again. I want that to be a solid line. Let's make it a different color. Okay? So here's that. Here's another side over here. Here's side. Anyway. So here's side A, which is equal to the height of the triangle. Here's side B. Here's angle A. So if A equals H, then how many triangles do I have? 1. So we're going to go through, examples of each of these in a minute, but I kind of want to show you all the different possibilities. So those are the first 2 cases. Case 3, okay, with an acute triangle, is that case 3. We're going to get my arrow tool again. We're going to put an arrow on this. Go this way. Go this way. No arrow on the end now. Now I'm learning. Case 3. Let me look at my notes. Is that okay? In this case, here's B, here's A, here is angle A. In this case, A is bigger than or equal to B. How many triangles could I have? If A is bigger than B, could I swing this side over here to make another triangle? No, because, or even if it's equal to, I couldn't swing it over here and make another triangle. I could make an isosceles triangle, right? But I couldn't make another triangle. So if A is bigger than B, then you have 1 triangle. Okay? So if I were to extend this side over here, I would have 1 triangle going like over here. Okay? And case 4 is when you have 2 triangles. So case 4, let's see if I can fit it in here. Case 4 is when you have a triangle. Oh, I don't want arrows on the end of my lines. Got arrows on. So case 4 looks like this. Here's my line. Here's my other side. Here's angle A, and here's side H. There's H going down. That's not very good. H. Oh well. Anyway, we'll call this H. H. Here's side B. And in this case, I'll draw side A in pink so you can see it. So side A, maybe it goes, oh, it's not pink. It could go this way, or it could flip over here, and it could go, let me draw in a different color. It could, oh, I want this. Why is it not turning pink? It should be pink. Or I could have A being over here. So in this case, where A is less than B, but bigger than H, then I have two triangles. Two tries. And so in that case, I'd have one triangle over here. There's my one triangle. See that one triangle? Given this angle, this side, right, and this side. And here's another triangle with the same angle. This angle, this side, and this side over here, right? So there's two different triangles going around. There's this triangle right here, and there's this triangle right there. Got it? So that's the that's if you have an acute angle. If you're given an acute angle. If you're given an obtuse angle, it's a lot easier. Okay? Obtuse angle with side angle. So say I'm given one side. Let's make it like this, and then another side going like this. So say this is, so here's my side B, and here's side A over here. If it's an obtuse triangle, here's angle A, it's an obtuse. A is obtuse, being bigger than 180. And here's A. How many different possibilities are there? If A is bigger than B, how many triangles am I going to have? Exactly one, right? Because it could either, if A is bigger than B, I could make a triangle here. I could make, I could make this. If A is really long, it's going to look like this. If A is just a little bit bigger than B, the triangle would still be an obtuse triangle right there. But if A is less than B, what happens? What if A is less than B? Can I make a triangle? No triangle. Okay? No triangle. And if A is bigger than B, A is greater than B, then you have one triangle. So when you have you're given an obtuse angle and the side opposite angle, there's only two possibilities. You either have no triangles or one triangle. So the hard part comes is when you have an acute angle and a side opposite that thing. Okay? Got it? Okay, so let's do some example problems. You ready to do some example problems?
Yeah, sure. So 19 wouldn't be an ambiguous case because it was close man.
19, would 19 be an ambiguous case? Sine of, should we do that one? Let's redraw the triangle, okay? So, let me look at number 19. What are you given? Sine of A, or you're given A equals 110, right? A equals 110. And you're given side A is 125, right? Sine A is 125. Okay, and then what else are you given? side B, B side B equals 100. So what I would do, so this is the way I take you through a problem like that. I would do a problem like that. First, I have to stand over here. It's easier for me to see. So first, I draw a side over here. I'd call, oh, we know this is obtuse angle, right? Ah, here we go. So this angle is 110 over here, right? 110. Side A is 125. Okay? Side A is 125, and side B is 100. How many different triangles can I have with those dimensions?
One.
Exactly one, right? Because A is bigger than B, right? Because A is bigger than B, and you have an obtuse angle, so you can only draw one triangle. So yours works fine, right? Okay. But if I were trying to solve this one, you would solve it just like Catherine did over there. So say I want to find angle B. Let's just do this one. So there's no ambiguity here. Ooh, isn't that a good word? So you would set it up just like she did. I want to show you how you do it on your calculator, just so you know. So you go sine of 110 is to 125 as sine of B is to 100. And so they'll say solve the triangle, solve the which means solve the angles and all the sides. Well, you already have two sides, so all you have to do is, it's harder in a sense, but it's easier in a sense also, because once you find one angle, you're kind of done, because all you have to do is subtract from 180 and find that other angle over there. Okay? So to do that, I'm gonna solve for sine of B. So sine of B equals 100 times the sine of 110. Right? Whoops. Sorry. Let's try that again. 100 times the sine of 110 divided by 125. Okay? And if you do that on your calculator, you get a number. And you want me to do that on your calculator? Sure you do. Second, quit. Where's quit? Quit. Y equals, oh, I don't want to y equals clear. And I want to make sure that I'm in mode. Mode, no mode. Where's mode? Here? Mode. Make sure you're in degree mode before you do these types of problems. Okay? And you always, so, second quit. So I'm just going to go 100 times the sine of 110. Okay? And I'm going to divide that, and I don't think you have to worry about extra parentheses, by 125. And if you get a number that is not between -1 and 1, you've done something wrong. Okay? Because sine can only be between -1 and +1. Remember that? So what am I going to do with that inverse? Oops, sorry, I just gave you the answer. What am I going to do with that number? So I want the inverse sine. So it might be better to take, you want B, right? B, angle B, is equal to the inverse sine of that answer, okay? Which I already have in my calculator. So you don't want to like round it off or anything like that. All you have to do is go second sin, okay? Second sin of second answer down here. See where that is above the negative sign? And then you close the parentheses, and then you hit enter, and you get that angle is exactly like Catherine said it was, which is 48.74 degrees. And once you know that this angle is 48.74 degrees, right? 48.74 degrees, then you can figure out this angle by just subtracting from 180 and finding that angle up there. And round off to like 100th place or something like that. So what's that angle? 110, 158. What's that? 21.36? Did I do that right? Yeah. 21.36 degrees up there. Okay? Easy? Okay, so let's do one. Did I do that right? Okay. So let's do that. Let's do an ambiguous case one. So, and sometimes they'll tell you there's two triangles, but sometimes you'll just have to figure it out. So solve for two triangles. So maybe they'll say there's two triangles, but maybe they won't, and you'll have to figure that out. So A is 15. A equals 15. B equals 25. And A equals 85 degrees. And they're kind of nice to you in this book because it seems that they always call A is always an angle down in the corner. But if they said that this were B and this were B, I would just drop B down in this corner, you know what I mean? And kind of switch your variables. You'll see. Don't worry about too much what you're calling the letters. Just think of that side out. So in the one case, you have this angle being 85, which is a pretty steep angle, right? So you have an 85-degree angle here. You have, this is A. You have B being 25. And you have A. Wait a minute. Is this going to reach? It doesn't look like it's going to reach, does it? Oh, this was the wrong example problem. Sorry. Because if this side is 15, do you think it's going to reach?
No.
No, because if you did find H here, to show that, you would first find H. And the way you would find, I didn't really talk about that. The way you would find H, okay, is, it's a good thing to talk about it. So to find H, you're going to use sine. You're going to use sine of 85 because this height makes a right triangle, right? So you'd say that sine 85 is equal to H over 25, in which case you get H equals 25 sine 85. And if you did that, what do you get? 25 sine 85 equals 24.9. Okay? So if H is 24.9, okay, that means that A is less than H, so it's not going to reach. Follow that? Okay? So no triangle in this case. No triangle, so you can't solve this one for two triangles. That one's a no triangle. Okay? So let's do one where you do have to find two triangles. Find two. Oh, I can't read my own writing. Here we go. Let's pick a different color. What color do you want? Let's choose from our palette here. You can pick a color.
Bottom right.
Make your own.
Bottom right. This one? Okay.
Yes.
Okay.
Make
Hold
the
on a
background
second.
black.
How do I do that?
I don't know.
We have to pause. This is really fun though. Watch. Pause this. We're going to get a new page. Whoa. We're going to hide this and we're going to use white.
Chalkboard.
Okay, chalkboard. And do you like this? You don't know yet. All right. So first we're going to say find two triangles. For which A equals 12, B equals 12, B equals 31, and angle A equals 20.5 degrees. Right? So again, draw your picture. Well, can you see that?
No.
Not very well. We're going to have to change that color. I can do that. We can change it to red. Okay, so
Green backboard.
fine. I don't know if I like this. So here's B is 31. So we'll call this 31. And I'll just assume that we found H, and we found that that A is between H and between H and B. So here's one possibility where this side is 12, okay, and this angle is 20.5. So now to find this angle B over here, and it's just what we did before, we're going to go sine of B is 231 as sine of 20.5 is 212, right? And then you cross multiply and you get that B is equal to the inverse sine. I'm just going to plug it all in one. Of 31 sine 20.5 over 12. And so all I have to do is stick that whole thing in my calculator in one chunk. Okay? And if I did that, I'm not going to do it in the interest of time and people fall asleep. So I'm going to put in that angle B is about equal to, angle B is about equal to 64.8 degrees. Okay? So if this angle is 64.8, I'm not quite done yet because I still have to find this side over here, right? So I still have to find side C. How do I find angle C? Yeah, I have to subtract from 180. So 180 minus 20.5 minus 64.8. What do I get? Who can do that in their head? What do you get? You get exactly 96.7. Why not? So this angle up here is 96.7, and then you would sine of this is to this, as sine of this is to this, or sine of this is to this, and then you would find the other side, which comes out to be, it's 94.7. 94.7. Okay? 94.7. Right? I listen to that station a lot. Okay? So this thing, I don't know what 94. So this angle is 94.7. And then this side comes out to be about, if you did that, 34.15. Now the other possibility is that this is an obtuse triangle. Okay? So you start again, and since the sine of an obtuse angle that is supplementary to this is exactly the same as the sine of that angle. Okay? So the other possibility is that this triangle looks like this. This is still 20.5, okay? This is still 20.5 degrees. This side is still 12, but it's coming down this way, okay? Like that. And we don't know what this side is yet. And this angle right here, since the sine of the supplement of 64.8 is the same as the sine of 64.8, right? Because sine is positive here and here, right? So the sine of this angle here is the same as the sine of this angle. So there's my other possibility. So what I do is I subtract from 180, I subtract the angle that I got over here, 64.8, and that gives me my other possibility for that angle, which is what? 115.2, okay? Which makes this angle up here 20.5 minus 150, or 180 minus 115.2 minus that, makes that angle up to the top 44.3, and then you'd have to find this side. Sine of 44.3 is to this, the sine of this is to this, and then you would finish out the triangle. Do you get that? Okay, so that side ends up being 23.93 right here, 23.93. So it's a totally different triangle, given the same angle, the same side, and the other side. Okay? There's one more little thing I got to show you, and that's the area formula for oblique triangles, and it's kind of cool. Yes, sir. Okay. Last thing, area formula for oblique triangle. So you guys know how to find the area of a triangle. What?
Isn't it the same as a right angle triangle or any other triangle?
Yeah, but it gives you a shortcut for doing it. So let me show you. Man. Watch. Here's an oblique triangle. All right, good artist. Look at that. Okay. So here's an oblique triangle. If I were to drop down the height of this triangle, the area, and let's call this side A. I want to show you where this comes from. This is H, right? And this is, we'll call this side C. We'll call this angle B. We'll call this side B. We'll call this angle B. So we know that the area of this triangle could be found by multiplying C times H divided by 2, right? Base times height divided by 2. But there's a shortcut, because I can write the sine of A is equal to H over what? H over little b, right? Which means that H is equal to B sine A. Yes? I solved this for H. And now if I take this and plug it in here, right here, I get a neater formula which looks like this. Area is equal to BC sine A divided by 2, okay? Which is equal to, and it can be shown that this is also equal to AC sine B divided by 2, which is also equal to AB sine C divided by 2. And this is the area formula for any oblique triangle, which is kind of cool because you don't have to find the height. All you have to do is know two sides and the angle in between them. So what's important to know, not what the letters are, but these two sides always surround this angle, okay? So for instance, let's find the area. Say this is 5, and this is 6, and this is a 30-degree angle. Let's find the area of this triangle. Area equals 5 times 6 times the sine of 30 divided by 2. I made this one work out nicely. Because what's 5 times 6 is what?
30.
What's the sine of 30? You should know that. 1/2, okay? Divided by 2. So I get 15 divided by 2, which is equal to 7.5. See how cool that is? So all you have to know is two sides, this side, and the angle in between them. If I were given this side, and this angle, then I could find the area. If I were given this side, and that angle, then I could find the area. And that's that formula, okay? And that's it. And your homework is on my Cutting Edge website. Where is it? There's my Cutting Edge. That's not my Cutting Edge website. This is my Cutting Edge website. And your assignment is recap assignments. Very nice. Sorry it was so long. But oh, did I hit the wrong chapter? Chapter 6. There it is. Let's make it bigger. Okay? You were gonna say that, weren't you?
Yes.
Not that bad. There you go. Okay, bye Savannah, I hope you're still awake.
Just got